This is your lesson on vectors in a plane, 6.3a. In this lesson, you will represent vectors as directed line segments, write the component forms of vectors, and find the magnitude of vectors given the component form. And perform basic vector operations and represent vectors graphically. So we're going to start. Oh yeah! Vector. A vector is different from numbers that we normally deal with in math, in that quantities are just represented with one number, like time, mass, or speed, or area. Whereas a vector has both magnitude, the length, or how large that number is, and the direction. You have to know which direction that number is going. And those are like forces or velocity. So what's the difference between speed and velocity? Well, speed is just the magnitude of a number, whereas velocity is actually a vector because it tells you that it's 92 miles per hour. And since it's negative, we know that by convention, left is negative and to the right is positive. So now we have a direction on this, then this is now a vector. If we set that this number up here is a vector, then we know it's going to the right. But speed, it doesn't matter if you're driving 92 miles per hour to school or from school, you're just going 92 miles per hour. That's your speed. Like the speedometer on your car, it doesn't tell you a vector, it doesn't tell you which direction you're going. But velocity, you do have to tell which direction you're going because it's a vector. Oh yeah. Okay. These quantities are represented by vectors. Like this initial point here, 6, 1. And the terminal point 4, 2. Initial just means where it starts, and terminal is where it ends. This looks like a ray, even though it's not. This is a vector. This is the actual length of the vector. The magnitude is the length, and it ends here, whereas a ray goes on forever. We're indicating, this arrow indicates which direction we're going, and not necessarily that it goes on forever. Okay, so the vector has a magnitude, it definitely has a length, this length right here, and the direction. Okay, examples are like 120 degrees or 43 centimeters. And we write the notation for a vector like this with these little, almost like greater than and less than brackets to show that it goes -2 to the left and 1 up. It goes from 6 to 4, so it went to the left, 2 to the left, and then it went 1 to 2, so it went up by 1. From 1 to 2, you go up by 1. From 6 to 4, you go to a -2. All right, so that's how we do that. These all vectors are all the same vector. We call them equivalent vectors. They have the same length and they're pointed in the same direction. Okay. A vector in standard position. If you put the initial point, the starting point at the origin, 0, 0, then that vector is in standard position. And the magnitude is how long it is. We like in standard position because it makes our formulas much easier. And to find how long this is, we use the distance formula, or the Pythagorean theorem. A squared plus B squared is equal to C squared. That's a right triangle, right? So we know that the length of this hypotenuse, or the vector, the magnitude of the vector, is going to be 2 squared plus 4 squared is the magnitude of the vector squared. So we need to take the square root. So this is about 4.5. So you can see like this is a little bit longer than 4, right? If this is 4 up here or 4 in both of these directions, then this is a little bit longer if we straighten it up over here. All right. Another concept here is a unit vector. We'll be using this a lot in a little bit, but a unit vector is just a vector that has a magnitude of 1. So the distance, the length of it is 1. And if you think of it, this is like the radius, and there'll be 1 going up or 1 going to the right or 1 going this way. So it's going to be like the radius. So that's length of 1. If it's length of 1, we call that a unit vector. A zero vector is a vector that has a 0 magnitude, or the length of it 0. Starts and ends in the same place. Okay, we can use this fancier formula for the magnitude. This is just the Pythagorean theorem. We subtract the two x's. You subtract the two x's, the end point minus the initial point, right? The end point minus the starting point, the terminal point minus initial point. A squared plus b squared, and then that's equal to c squared, so we take the square root of both sides, and this is how we get our formula. So the components, the direction of vector v. This is a component form. A lot of questions will be asking you for the component form. It says how far to the left or right it's moving. That's the first part. And how far up and down. You can think of the x direction and the y direction like an ordered pair. So the horizontal movement is the x2 minus x1, the endpoint x minus initial point x, okay? And then for the vertical component, the second number in the component form is the difference in the y's. So for this vector, even though it starts at 5, 1 and ends at 3, 4, it's the component form of this vector is 2 to the left, negative 2, and 3 up. Or you can just subtract the endpoint, 3 minus 5, and 4 minus 1 will also give you a negative 2, 3. All right. Give the component form of and the magnitude of this vector. So the component form is how far to the right and left that we go. We went to the right 1, 2, 3, 4, 5, or we can take 7 minus 2 will give me 5. Then we went up 3, 4 minus 1. So this is the component form. This gives me the direction. And you know the vector has a direction and a magnitude. And how do we find the magnitude? We take a squared plus b squared. We take the square root. So a squared plus b squared. All right. That's 25 plus 9. So that's 34. Take the square root. We get 5.8. So the magnitude of this is about, the length of this is about 5.8 in the direction of 5 to the right and 3 up. So here's your direction, magnitude. Hey, try and do this one without watching me do it. Get the answer and then come back and look at it, okay? Find the component form and the magnitude of vector v that has an initial point of 4, negative 7, the initial point, and then the terminal point of negative 1, 5. Okay, when you're ready, you can look at it. All right. This is 4, negative 7. And so we're going to subtract those. Negative 1 minus 4. And then 5 minus the negative 7 gives me 5 to the left and 12 up. Okay, you know that if you started at 4 and you ended up at negative 1, you went 5 to the left. If you start at negative 7 and you end up at 5, you went up by 12. Now to get the magnitude, Pythagorean theorem on these two numbers, then we get negative 5 squared, which is 25, positive 25, and 12 squared is 144. Add them together, 169. Take the square root, the magnitude is 13. Yay. Here's one more quick one. Why don't you do this? Check your work. All right, so we're doing the same thing, and the component form is 6, negative 9. And then the magnitude is 10.82. All right. Okay, now let's do stuff with our vectors. We can multiply them by a scale, okay? Scalar multiplication. This is really easy. We're just going to multiply by a number. So here is vector v. Here's 2 times v. It's twice as long. This is 1 inch. This will be 2 inches. And then this will be half an inch. And this will be a negative because it's going in the opposite direction. So k is some number that you're multiplying the components of the vector with, and it's just k times v1 and k times v2. So this is our vector v, and it's 1 comma negative 4. And then 2 times v would be just 2 comma negative 8, because it's 2 times 1, which is 2, and 2 times negative 4, negative 8. Vectors can be added together. If we take vector v and vector u, we can add them together. Now this is kind of important. When you add 2 vectors, you put head to tail, not head to head, not tail to tail. So we put them head to tail. That's how we add them together, and then we're going to draw that line in there. Okay? Or you can do it the other way. U plus v, I'm going to take u and add that to v, put that head to tail, and we're going to get u plus v. Notice, starting to notice that we're making little triangles here, right? Okay. So you notice that v plus u and u plus v are equivalent, right? Because these two are actually the same. It doesn't matter which order we do them in. Okay, so u plus v is equal to v plus u because of the commutative property. You can do addition either direction. All right, so if you're adding v and u, then it's going to be 1 plus 7 and 2 plus 3. Addition of vectors. Okay, now v plus u, if we put them head to tail, we draw it this way. Okay, or u plus v. Okay, this is the same thing as what I just did, but I just want to show you that they're the same in the middle. But you notice what happens when we draw them both together, when we get a parallelogram. Your sum is always going to be the diagonal of that parallelogram. Okay, let me go back here. All right, so if you had to add these two together, if you make a parallelogram out of these two pieces and then draw the diagonal in between, that's how you get the sum, or you draw the sum. All right. Sketch a graph of the specified vector negative v. So here's v, negative v. You're just going to point it in the opposite direction, exactly the opposite. So if this was, let's say, 2 comma 3, it'll be negative 2 comma negative 3. Okay, just exactly the opposite direction. Let's do another one. How about 3 times u? Here's u. 3 times u would be like that. 3 times as long. Okay? What about u plus v? Remember u plus v, head to tail, or make a parallelogram? So you're going to head to tail and put that there. So that's how you get u plus v. U minus v. Well, u minus v is u plus a negative v. So first, let's get the negative v and add those two together, head to tail, and then you're going to get u minus v would be this one, right? It's kind of hard to see this way, but if you look at it that way, okay, you go in the opposite direction, put head to tail, and then you should have it. All right. How about u plus 2v? Take u. First, we need 2v, and then add the u, and we're going to get that. So that's u plus 2v, head to tail. Okay. What about v minus 1/2 u? So there's v. We're going to flip this the other way and take half of it. Okay. flip it the other way and take half of it, and then we put head to tail. Okay, now it's v plus a negative 1/2 u will be that right there. Okay, all right, so I'm going to do these three. Here are my two vectors, vector v and vector w. Find and sketch the vectors 2v. So 2v, this is a scalar of 2, so we multiply those by 2. So if you watch me do this, you're going to get 2 times negative 2, comma 2 times 5. You get negative 4, comma 10. I'm going to sketch that. So again, that's my v. It's negative 2 to the left and 5 up. Now 2 times that would just be like that. So there's the answer. Part B. So we're going to subtract them. So this is going to be w minus a negative 2, right? So 3 minus negative 2 and 4 minus 5. So I'm going to end up with 5 comma negative 1. 3 minus a negative 2 is 5. 4 minus 5 is negative 1. In drawing that, first we're going to draw the the w and the v, and then the sum of them would be that one right there. C. So you have v, this is v, plus 2 times w, and 2 times w is 6 comma 8. Add these together, I get 4 comma 13. Now sketching it, I'm going to sketch v first, then sketch 2w, and then add them together. Okay, you're going to do these three. Okay, these numbers haven't changed. Do them, sketch them out. Use some graph paper so that you can actually see what's going on. Okay, and then come back here and look at it and see if you did it right. All right, so I got 6 comma 8, and it would look like that. 6 comma 8 because it was 3 comma 4 twice. Okay, part B. V minus w will be negative 5 comma 1. So you draw v, draw w, and then since it's going the opposite direction, it's subtracting, I made it go that way, and then add them together, and that's how you draw that. 5 to the left and 1 up. Okay, last thing here, w plus 2v. There you go. And that should do it right there. All right. Okay, so your Google form, because of the graphics here, the picture, I actually had to put the first 3 questions of your Google form on the video. So number 1, give the component form of the vector. Give the component form of this vector. Number 2, give the magnitude of that vector. Number 3, which one of these is the sum of u plus v? These 2 blue ones. Which one of these would you draw as their sum? Okay, and the rest of the questions are on the Google form. Thank you for watching.